Hey, what's up? It's Powell, and in this video I'm going to go over polynomial long division, which is very useful when you have to factor and solve polynomials of any degree. And like regular long division, it's set up very similar to regular long division, but it's a little different only because we're using polynomials rather than just numbers in general. So here we have 3x squared plus 11x plus 1 divided by x plus 3. And just like we normally would with long division, 3x squared plus 11x plus 1 is our dividend. It goes under the fraction bar, and x plus 3 is our divisor. Now, here's where it gets a little weird, because like with regular long division, you want to cancel out the first term. So when you multiply the quotient by the divisor, you want to cancel out the first term of the dividend and then go on to the next one and drop the next one down and do the same process until you get a remainder or 0. The first term is 3x squared, and we're dividing by a binomial. So I want to figure out what I can multiply x by to get rid of 3x squared. And that, of course, is 3x. So because it's 3x, I'm going to write that above the term that has the x, the one with the same degree. And that's mostly just for organization's sake. So I take 3x and I'm going to multiply by x plus 3. And we're going to be distributing over x plus 3. It's not generally set up the way we normally would do it, but 3x times x would be 3x squared. 3x times 3 is 9x. And just like with long division, I subtract the lower one from the upper one. So 3x squared minus 3x squared is 0. 11x minus 9x is 2x. And I do the whole process again. I want to figure out, but first of all, I have to drop down the plus 1. Now I want to cancel out the 2x, so I need to figure out what I need to multiply x by to cancel out a 2x, and that of course is plus 2. So 2 times x gives me my 2x, and then distributing it over the binomial, 2 times 3 is plus 6. 2x minus 2x is 0. 1 minus 6 is negative 5, which is my remainder. So what do we do with the remainder in this case? Well, I know that the quotient is 3x plus 2 at least. So this equals, get over here, equals 3x plus 2. But because of the remainder theorem, what I have to do is I have to take my remainder, which is negative 5, and put that over the divisor and just stick it on the end of it. So we get 3x plus 2 minus 5 over x plus 3. Now, just to kind of show you why that works, I'm going to check it down here where if that is the quotient of this division problem, if I take the quotient and multiply by x plus 3, I should get what I started with, 3x squared plus 11x plus 1. So I'm going to take 3x plus 2 minus 5 over x plus 3 multiplied by x plus 3. And we'll see what I get. X plus 3 times 3x, so 3x times x is 3x squared. 3x times 3 is 9x. Then 2 times x is 2x. 2 times 3 is 6. And then negative 5 over x plus 3 times x plus 3 is minus 5, because the x plus 3s will divide away. And then if I clean this up, I get 3x squared plus 9x plus 2x, which is 11x, and then 6 minus 5, which is 1. So notice that is the same thing I started with. So it works. It's a really weird looking answer, but it works. With synthetic division, or with polynomial long division, and with synthetic division when we get there, there's a certain thing you have to do to ensure that all the terms line up. And it only occurs when you have terms that are missing. So here we have 5x to the fourth plus 14x cubed plus 9x divided by x squared plus 3x. Now, when I write my dividend under the fraction bar, I have 5x to the fourth plus 14x cubed. But you'll notice there's no x squared term. Well, because there's no x squared term, I do have to account for it. But because it's not there, I'm going to write it as 0x squared. Trust me. And then plus 9x. And then notice there's no constant term. There's no term with no x on it. So I'm going to put a 0 at the end as well. So this accounts for the fact that we have no squared term, no quadratic term, and this accounts for the fact that we have no constant on the end. So you have to make sure you have a term that represents every degree in descending order. And then divide by x squared plus 3x. So like before, I want to take x squared and cancel out the 5x to the fourth. Well, what can I multiply x squared by to get 5x to the fourth? That would be 5x squared. So 5x squared times x squared is my 5x to the fourth. Because I'm distributing through, 5x squared times 3x is plus 15x cubed. And then 14x cubed minus 15x cubed will get me negative x cubed. So remember, we're always subtracting the second one from the first one. So now I need to multiply something by x squared to get negative x cubed. Well, that's negative x. So negative x times x squared is negative x cubed. Oh, I forgot to drop down the 0x squared. So negative x times x squared is negative x cubed. Negative x times 3x is negative 3x squared. Now the negative x cubes subtract away, and I have 0x squared minus negative 3x squared. Since I'm subtracting a negative, that becomes positive 3x squared. Again, a lot of these weird things happen. Now I drop down the 9x, and now I want to get rid of a 3x squared. So what do I multiply x squared by to get 3x squared? Well, it's plus 3. So 3 times x squared is 3x squared. And then 3 times plus 3x is plus 9x. And when I subtract them both, I get 0. There's no remainder. So since there's no remainder, my quotient is 5x squared minus x plus 3. And that means that this is a true factor of 5x to the fourth plus 14x cubed plus 9x. And I can do a lot more of examples of these because a lot of weird things happen, and we're going to see similar things happen when we do synthetic division, which is very similar, but again, a little different. If you like this video, please subscribe and comment below on any topics you'd like me to cover in the future. And again, stay tuned for more polynomial long division and some synthetic division. Thanks for watching.